Welcome. This workshop is about virtual reality and especially how to get PointCloud data, such as the 3D scan that you saw behind me, into Unity 3D and then eventually pushed onto the Oculus Rift VR headset. I used a fairly low-cost 3D scanning device, the Scanse 3D LIDAR scanner, and if you're interested in how to build one of these yourself, it's a do-it-yourself DIY project, you can find the link to instructions in the comments section of this video. So let's get started, and I will show you in the screen view how you can put together a project like this yourself. Okay, so for this project we actually need to start by making sure we have the Oculus software installed on your computer. And you can do that by going to the Oculus website that I've already pulled up here. You can get the URL for this website in the text section of this video. So just download the software, install the software on your machine, and get yourself an account with Oculus so that you're able to log in. And then after you've done this, you can actually start the software, and you need to make sure that all your devices that are needed for the Oculus Rift are connected to the computer. So usually I think this window would look something like, I think it always starts with the store. So when you open up this window for the first time, you would see something like this in your Oculus software. Then you would navigate to the settings that are right here in the top right corner. Click on that. And in the settings under devices, you will find all the devices that need to be connected to your PC. So you see I already connected my Oculus Rift headset. This is connected, so it's very good to see that. I connected the sensor, set that up, and these are all things that you will be guided through in the installation process, how to set them up and how to calibrate them also. And then you also have the Xbox controller right here that is on, which I'm going to use in Unity in order to navigate through the scene. So this is all very good. All three devices are connected, so I can hide that window again. Don't close this. This window actually needs to be open while you're working on some of the other parts of this project. But this is just a good way to know that all of your devices are actually on and are being recognized by the system. So in the next step, we actually need to download the 3D scan files, one of which you've already seen in the beginning of this video from our gallery on campus. And you can do that also by going back to your web browser and then going to the class website, and then where it says sample 3D scans, this is where you can get the files from. So it's a zip archive. It has a couple more 3D scans other than the one from the gallery, so there's something to explore and something to work with in here. And you can also find, again, the link to this class website, the link to this zip file in the text section of this video. So as you can see, I've already downloaded these files. They're actually right here in the sample scans folder and are ready to be used then. The next step we need to download and install is actually two pieces of software that allow us to see and then also modify eventually these 3D scans that we have created. And the two pieces of software are the Scanse Sweep Visualizer first, and then CloudCompare as the second piece of software. So let's go back to the Scanse Sweep Visualizer. You would click on the download button and then install this software. This is a really easy, lightweight piece of software that allows you to very quickly see your 3D scan files, and also makes it fairly easy to actually stitch multiple 3D scan files together and then save them as a kind of a complete data set that you can then open in Unity. We can take a quick look at this piece of software, have it installed right here, and then maybe open one of the scans already that we've taken. Probably go back to the gallery scan. And so you find this under the map section here. If you go to map and then say add PointCloud, you can then navigate to your files, and they're in this case on the desktop in my sample scans folder. And then if I go to the roof gallery, 1 Hz, 1000 Hz CSV file, I can open this in the software. As you can see here, the input that this software takes is actually the PointCloud file format. It's either a CSV, XYZ, or PLY file. So, but for now, let's just open the roof gallery test file, hit the open button here, and then you see this is actually our data set, and you can already navigate it and take a look around in the gallery here. You can enable certain properties for this file, such as transforms, so that allows you to move and rotate this point cloud to actually align it with other point cloud scans that you may have made. And you can do a very simple data removal that basically takes into consideration the signal strength of your scan. So there isn't much more that you can remove other than what is in the file tagged as a weak signal. So you'll see that CloudCompare eventually will give you much more precise tools to remove individual points very specifically. And then if you're done, let's say you wanted to combine point clouds in here, you would just say export map again, and that would get you to a save file dialog that allows you to export what you have created in this software. So this is the Scanse Visualizer. Let's close this here for a second, and then let's take a look at the second tool, CloudCompare, that I've already opened on the website here, and you can see there's a download section for this one as well. So download this software, install it on your machine. It's both Mac and PC compatible, also such as the Sweep Visualizer. So both of these will run on all of your computer systems that you may have. So if you take a closer look at this for just a second, you will get a kind of a feel for this software as well. And many of you will probably choose to work with your point cloud data in this software since it's much more powerful than the Scanse Sweep Visualizer. It's maybe also in the beginning a little bit less intuitive to work with, but there's a great set of tutorials on the CloudCompare website, and I have also provided some links to these tutorials in the comments section of this tutorial here. So you'd go to File, and say Open. And if you don't see your 3D scans in here immediately, I already navigated to the desktop in order to see them, but it may be that this opens up just telling you to look for CloudCompare entity files, these bin files. Then you actually wouldn't see your scans in here, so you have to make sure that under Files of Type, All is selected, and then that will give you a list of your 3D scan files that you can open. So again, I want to open the roof gallery file here, the open key, and you have a window that starts up at first that allows you to align the X, Y, and Z coordinates and the signal strength, which is this fourth column right here under scalar. And these already match up pretty well, so you don't have to change anything in the assignment of these different values. You would just basically hit apply, and that will open your model also in CloudCompare right here. And you can take a look at this, zoom in a little bit, and then rotate it, and so forth. As I said before, this is probably a more powerful piece of software than the Scanse Sweep Visualizer, because it will also allow you to remove certain points, such as here, these stray points that you see shooting out of one of the doors in the gallery. So you could actually draw a selection around here and then have these points removed. You can also combine and align point clouds a little bit more precisely in here by choosing individual points, 3 points or more, that are available in both point clouds and represented in both point clouds that you want to align, for example. And you can take subsamples of your point cloud data. That means you can reduce or spread out more evenly the amount of points in your point cloud. So for example, here we see that there's a high density of points in the ceiling, so relatively low density of points the further out we get in the gallery space. And so you could say, I want to more evenly distribute these points, so maybe thin out a little bit the ceiling and then keep the overall density of the points intact for the walls here. So you could do something like this in CloudCompare as well. Again, check out the tutorials that are really great and helpful. These are all video tutorials for how to use the software, and they are featured in the text section of this video. So after you worked with your PointCloud data in either the Sweep Visualizer or CloudCompare, it is now time to get this data into Unity and eventually pushed onto your Oculus Rift VR headset. We are lucky that the folks at Scanse have actually created a Unity project for us already that we can use and that we can build upon or that we can modify. And you can find it on this website here. It's actually part of a GitHub archive. And you can basically go to clone or download. You get there, download this as a zip file, which will save this little folder onto your desktop. And in here, you will actually find the Unity 3D file that we want to open next. So I go to Unity, open this file right here. And if you're on the PC, this file works straight out of the box. So it will allow you, when you press the play button in Unity and run the program, to load a PointCloud into Unity. And then if you have your Oculus Rift VR headset connected to the PC, it will already show that PointCloud on there. So if you are in this software, you need to go to Asset Scenes. So in the main scene in Unity, you can simply click the play button, and that will open up a file browsing dialog. So you would choose your CSV data and make sure it can only be either in the CSV file format or the PLY file format. Hit the open button, and then it will load your PointCloud data into Unity. So depending on how many individual points your PointCloud is holding, how big your data is, it may take a little moment. But once it is there, you see that in your viewer, and now you can already put on your Oculus Rift headset and then use your controller and start moving around in the application. Good. So this unfortunately does not work so well on the Macintosh, and if some of you guys are actually using the Mac to author your Unity application, I can show you a little trick how you can still get your PointCloud data in there. Basically, the problem seems to be the file browser, this window that we just saw that opened for us, that does not seem to work well on the Macintosh. So what we have to do in this case, we have to actually take a look at this PointCloud generator game object that has a PointCloud generator script attached to it. To open this script, and you can double check on the PC. Sometimes the external editor is not mono develop, which I would like in this case, but it is Visual Basic or Visual Studio or something like this. So I need to just go to the preferences here quickly under Edit, and then under External Tools, I need to make sure that under External Script Editor, we have the mono develop built-in editor selected. So that seems to be fine. And then I can go to the PointCloud generator script. Again, that's attached to the PointCloud generator game object, this empty game object here. And then you can simply double click on that script and open it in mono develop. Okay, so here we are in mono develop. And if you take a closer look at this file, you see that there are actually quite a few comments in here that make it relatively easy to read what's going on. And so the first thing we actually need to completely comment out is this part here, where we want to open a native file dialog window. Since this doesn't seem to be working well on the Macintosh, let's comment this out. So I put a backslash, or slash actually in this case, oops, slash star, and then another star slash to end this. Now, unfortunately, we also have to do a couple of other modifications. So first of all, we have to comment out this line of code, and we need to put our own string variable in here that we call file path as well. So I just copy this line of code, And what I do, instead of specifying an element in an array right here, that I actually should have gotten from this file dialog, I specify the exact file name. And for me, in order to do this, I need to copy the PointCloud data file into my Unity folder. So if I go back to my desktop and I look at this, and if I want to get the roof gallery 1 Hz, 1000 Hz CSV file in there, I need to make a copy of that. So copy. And then I need to paste this into the folder that my Unity project resides in. Paste. And I also need to paste the name of this file in here. Paste. Oops, didn't like that. So go back and select this, the whole name. There we go. Select this. Copy and close this, paste in here. So here we have the file name. And then the last thing I need to do is I need to also see there's some debugging output in here that still has a reference to this first element in the array here. Yeah, so right now it's right here in this part where it says print if it can't read the file, which in our case we hope this wouldn't happen, but we just say file path in this case, which will then refer to this variable that we just set up here, which refers to this file specifically. So this will load a file directly into Unity, bypassing the file browser window. So I just have to save this. You go to File, Save, and then I can go back into Unity. Updates the script here quickly. Hit play again. And now it should load the gallery PointCloud data file immediately without actually pulling up a file browsing dialog. So here we are. Could use our joystick again and then look around in the gallery and explore that with our Oculus Rift headset. So this is one thing you can do. This will make this application work for you also on the Macintosh computer. Unfortunately, on the Mac, you don't have the Oculus capabilities, so you would just basically work within your viewer here. But it is great already for debugging or for actually even putting your project together on the Mac and then finally pushing it onto the PC for the final build. So the next thing you can do is you can go back to the PointCloud generator game object, and you can investigate another script that is quite interesting, which is the adjust transform script that is in here. And you can see that you can enable or disable certain kind of functions that allow you to modify the size, the rotation, and the height of the first-person controller within the PointCloud in your application. And so these are all tied to keyboard shortcuts that you can see. If you just quickly hit the adjust transform script, it actually quickly pulls it up within Unity, and you can just scroll through that. You could also double click on that and open this in MonoDevelop. You can see that you can adjust your height in the space by using keys E and Q. You can adjust the yaw, which is the rotation around the y-axis in here, by using keys R and T, and you can adjust the scale, the overall scale of your PointCloud by using keys Z and C. So we can try this out and load our PointCloud data again. And this time I made sure to check all of these user settings. So now if you move around in the space, see a little bit better here, you can use the E key, which will make you move down with your first-person controller. You can use the Q key to move you back up. You can use the R key to rotate. This is the yaw property. R or T, rotate the PointCloud around you. Or you can use the C key or Z key to change the scale of your PointCloud data as well. So that is possible too. You do, however, as I said before, have to go to the PointCloud generator and check the adjust transform script and make sure that all of these settings are actually enabled in here. If some are disabled, these keys actually won't work for you. One last thing that I wanted to cover in here is the PointCloud CS script, which you find in here. And this one is responsible for coloring your points in the PointCloud. So right now it takes the signal strength into consideration and then colors your dots or points accordingly in this kind of yellow to red hue of color. You can change this, however, and so if you open this in MonoDevelop, I can quickly show you where this would be. And this script is open here in MonoDevelop, and you can see that under Clouds, this is where it goes through all of the individual points in your PointCloud data. It colors each of these dots with a very specific color. And so right now it takes the normalized signal strength for each of these points into consideration, and then sets up the red component based on that. So the green and the blue component, they stay the same. But you can change this to just a solid color if you like, and you could say colors I, and then instead of saying color HSV to RGB, just say I want to create a new color, so new color, and then you would just specify the RG and B setting for this color. So if you wanted all the dots to be green, for example, you would say 0, 0, floating point 1.0, floating point 0.0, and then close your parentheses, semicolon, save this quickly. Save. And then go back into Unity. Oops, this was the wrong one. Unity. And play this back, and you should see all your points in the PointCloud data should be green in this case, like so. All right, so there's another thing that you can do with this script and modify or customize it to your needs. The next thing I wanted to show you is combining your PointCloud data with actual game objects that you can create in Unity and that you can place in the three-dimensional space. And so just as one example, I wanted to show you the addition of just one simple cube in here, and how you would basically navigate the placement of this cube when you can only really see its relationship to the PointCloud data while the software is actually running. So let's just get the cube in here first, and then see how we can change or translate it in the three-dimensional space and then rotate it or scale it as well accordingly. I go to game object and then create a new 3D object, cube. So it's right here. I can move this up just a little bit so that it sits even with the ground, and then already play this back and see what this will look like. So there should be a cube in my green gallery space right now. All right, so I have to look through my goggles quickly, see where it actually is. So I guess I'm on the cube right now. Yeah, so it's right here in the gallery, right in the middle where I actually had my 3D scanner situated in the gallery. And here's a little trick how you can now start to move it. You can actually stop this again and go into your Windows configuration where it says Window, and choose under Layout the 2x3 Windows layout, which gives you a game window down here, and it also still allows you to see the scene while you're playing the game. You still have access to all of your game objects in the hierarchy window, and you have your inspector on the right hand side as well. So when we start this one, we now see in the bottom view the PointCloud representation with the cube in the gallery space, and in the window on top of it, right here, I get my mouse back, so you may have to press the escape key to get your mouse back. You see the actual cube in the gallery space. And so what you can do is you can now start, if you're in the translate tool, you can start moving this in the gallery around while you're actually looking at it through your Oculus Rift headset. And you can also, so if I wanted to place it, for example, in the corner way over here, and then you can inspect it if you like. To go back in here, I guess, be able to walk over there. So just clicking into this window, so it sits pretty well in that corner now. And then if you like, press escape again and then go back up into this window. You can also rotate it. So if you go to your rotate tool, you can start rotating it into the corner in any direction you like, and so forth. You could start to scale it using the scale tool and so forth. But here's the important part. Before you actually stop the game from playing, you actually need to go and take a look at the transform data that is just created during the gameplay, that is in the transform inspector window on your right hand side with the cube selected, and then note and jot down these values that you're getting for the position, rotation, and scale, if you also scaled this. Because as soon as I stop the game, it will actually move that cube right back to the center of my scanner. So all of the data that you've just generated by placing the cube in a different part of the gallery will be lost. So if I write down -1.85, 0.5, 3.49, and then a rotation around the y-axis of 41 point, what is this, 2454, and then stop the game. Now I can actually go and recreate this data, -1.85 and 3.49, and then the rotation around the y-axis was 41.254. Enter. Now if I play the game again, you will see that right from the beginning the cube will actually be in the right position in that bottom left corner of the gallery space where we actually interactively placed it before. Yes, so here we are. Just need to move a little bit back, so cube is right there where we left it in the gallery. All right, and so you can now bit by bit, game object by game object, start to decorate, in this case this interior space, or start to populate the gallery with other objects, other game objects as well, 3D models that you may want to load into Unity, or game objects that you create in Unity, for example interactive trigger zones, sounds that you may want to play in the space, and so forth. All right, and then at the end, if you're done with this and you want to go back into your regular view, you would just basically go to Window, Layouts, and then go to your default window layout, which is where you came from. Before I end this video, however, I just wanted to show you one more quick thing, what you can do. I wasn't really 100% satisfied with the behavior of the controller that the regular virtual reality support package for Unity gave me. So I can basically just navigate forward, backward, left, and right, and I can look around in the space, but I can't turn around my axis using the second thumb joystick on the Xbox One controller. And you can actually enable this by downloading a package from Unity directly that you can use instead of your first-person controller. And so I can show you this in the last step of this workshop. This is optional. You don't have to do that because it works fine right out of the box. But if you're interested in also getting a little bit deeper into all the tools that Oculus has to offer, you may want to experiment, get started actually with their Oculus Rift first-person controller. So this is the last website that I have prepared here. If you go to the Unity Developer Center, under Core Package, you see that there's the Oculus Utilities for Unity that you can download. And so I have done that already. They're actually on my desktop. I have to close a few windows here. All right, so here are the Oculus utilities, and then if you double click on that, you see that there's one Unity package in there that we have to get into our Unity application. So I go back to Unity, I go to Assets and say Import Package, Custom Package, and then I navigate to the Oculus utilities on my desktop and then open this package. Just import all of these components that are part of the package. If this window shows up, you can just say you made a backup and go ahead with the update of some of the scripts. Since I'm running the latest version to date of Unity 2017.2, there may be some updates required in the scripts. And then it will also ask you that it has detected an older OVR plugin, an Oculus virtual reality plugin, and that it should actually, or it wants to update this one. And in this case, it is recommended just to say yes, updating this plugin would be great. All right, and now we need to restart our editor. So Unity just restarted. I quickly edited out the part where the software closed down and then reopened just to save a little bit of time in this tutorial. But what you see in the assets folder is that we got a new folder called OVR. And if you double click on that and go to the prefabs, you actually find an OVR player controller that we can use instead of our first-person controller that we have used so far. What we can do, we can just delete this one and get our OVR player in here like this. And it's as easy as dragging and dropping this player controller in here. You could place it in a different part depending on where you want it to start in your game. And then just simply hit the play button again and try out the new player controller with your Oculus headset. All right, so this is what this looks like. The nice thing about this new player controller is that you can have access to the second thumb joystick on your Xbox controller. So I feel it's a little bit more user-friendly to navigate through the space. However, you see there's maybe one thing that might be worth changing in here, and then was I thought a little bit nicer in the first version with the first-person controller, is that now we have this skybox in the background that basically creates this horizon line or the rising sun with the blue sky. And so if you want to change this back to a completely black background, I can quickly show you how to do that. You would actually have to go to the OVR Player Controller, go to the OVR camera rig, tracking space, and then we have these anchors for the left eye, center eye, and right eye. And if you look at the inspector, you see that each one of these anchors has its own skybox attached to it. And so what you would have to do is go to your left eye anchor, change this where it says clear flags to a solid color, double click on your background color, change that to black. Do the same for the center, just enough the center eye controller, change that one to black. And then do the same thing for the right eye controller, solid color, change this also all the way back to black, and then play your application again, and now experience everything with a nice black background again, just like before. All right, so I can put my headset back on. We have our black background and our ability to navigate in the gallery space and take a look around here with both thumbstick controllers. So the last step that I have to show you is how to create a standalone application with this project. I want to author it for the PC, and so what I need to do in this case is I just quickly have to go back and change my PointCloud generator script so that we get the file open dialog again into Unity. So it's good that I just commented out parts before, so I can uncomment these and then comment in the additions that I have created, and then also take this variable back to where it was in here. All right, so save this, Control S or File Save, and go back into Unity, try it out just one more time, just to make sure that everything is running. So my files are on the desktop, roof gallery, open, okay. The data is here. Just make sure one more time I can navigate around everywhere and take a look at everything. Yes, so this looks great. So I can cancel out of this. Finally, we're at the point where we can export this project and turn it into a standalone application. And we would do that by going to File, Build Settings. Make sure that under Platform we have the PC, Mac, and Linux standalone distribution selected. Go to the target platform and make sure that's distributed for Windows. The Oculus Rift headset only works on this system. And then under Scenes in Build, here at the top of this page, we need to make sure that Scenes Main is selected, that we have a little checkbox marked right next to it. And then we can also check one more time the player settings. In the inspector, under XR settings, here at the bottom of this list, we need to make sure that virtual reality supported is checked as well, and we see that that includes the Oculus headset that we have connected to our system. So at this point then we can hit the build button, and we need to choose a place where we want to save this project to. So probably the desktop. I save this as PointCloud app.exe, hit save, and that will start compiling the project and turning it into a standalone application. So once this is done, it opens a file browsing dialog for us, and I can choose the app that I've just created. The startup screen allows me to set the screen resolution and the graphics quality here, for example. These initial settings are fine. You can experiment a little bit based on your computer system, make sure which one works the best, gives you the best quality with the best playback speed without any lag. So you may have to fine tune these a little bit. For now, these are okay though, and I just hit the play button. Need to probably in just a second here choose the file of PointCloud data that I would like to open up in this application. Hit open. And then I do have to put on my Oculus headset in order to see anything on the screen and in the headset. So here we are now in the gallery, and I can start navigating the space and explore everything I have just created in my project. So we're at the end of this workshop. I hope you enjoyed it, and you will enjoy even more creating your own applications, visualizations of PointCloud data in Unity, and experience them immersively on the Oculus Rift headset.